Hey guys, it's me, Miss Miller. It was so great seeing you on Monday, graphing sine and cosine live. But I wanted to also continue with our guided notes and finishing up sine and cosine graphs when there's phase shifts and vertical shifts changing our midline. So the next example, I've actually made an edit. So if you printed out the guided notes or are using the ones I gave you on Google Classroom, please note that instead of pi over 3 inside the parentheses, I've changed it to pi over 2. So the information that I'm asking of you is amplitude, frequency, period, domain, and range. Those are very common whenever you're working with sine or cosine, but there's other features that are important here, such as a phase shift. So let's first identify our amplitude is going to be that A value right here. And remember, amplitude is the absolute value. So our amplitude is 2, but we want to take a note because it's negative, we're going to have a reflection over the x-axis. So when we're multiplying our y values, what we're going to do is multiply by -2. Our b value, which can't be seen, is 1. That's the number in front of x. Because our frequency is 1 or b is 1, we don't need to factor it out. And our phase shift is going to be pi over 2 units to the left. And this is our starting value. All the other graphs we kind of started at 0 because there was no phase shift. This is where we start. And I can actually put that as my starting value in my table, pi over 2. And then we're also going to have a vertical shift. Up 1. That's going to change our midline to be y equals 1. So the period, remember, period is 2 pi over b. Since b is 1, my period is 2 pi. And that just means the distance of one full cycle. It doesn't mean that we're going to end on 2 pi, but rather that the starting point to our end point is 2 pi. Now, you can always know that your domain is all real numbers. We have even graphed and we're able to tell that. And we're going to use our range in a minute. Now, what I want us to do is figure out what we're going to count by or add to our starting value. So we take our period, 2 pi, and we're going to divide it by 4 because we want those 4 quadrantal angles. We want those 4 perfect angles that give us easy numbers to work with and graph. So we're going to count by pi over 2, which makes it easy. So for each of these values, I'm going to add pi over 2. And so, sorry, we're starting at the left. So we're starting at negative pi over 2, right? So I can even go ahead and label this. I'm going to give myself a little bit of room. You don't have to actually know. I'll just make this pi over 2 negative pi, pi over 2, pi, 3 pi over 2, 2 pi, pi over 2, 3 pi. You don't have to label the entire graph. I'm just giving us some room here. So we know what we're counting by. So if I add pi over 2, I get 0. Add pi over 2, I get pi over 2. Add pi over 2, I get pi. Add pi over 2, I get 3 pi over 2. And know this is the distance from negative pi over 2 to 3 pi over 2. That distance is 2 pi. That's my full period. And now for my sine value, sine always started at the origin. So 0, 1, 0, negative 1, 0. And we're going to use our amplitude. So everything's going to get multiplied by -2. But we also have to remember our vertical shift. So then after you multiply, you're going to add 1. And an easy way to remember that as well is that since your midline has changed, you know that this, you could draw an imaginary line if you'd like, is now where the graph comes to a center. So now 0 times -2 is 0, plus 1 is 1. Positive 1 times -2 is -2, plus 1 gives me -1. 0 times -2 is 0, plus 1 is 1. Notice the height going from -1 to 2, that's a distance of 2, that's showing my amplitude is 2. -1 times -2 is +2, plus 1 is 3. 0 times -2 is 0, plus 1 is 1. Label down here. And now we're ready to graph. So our first ordered pair is -pi/2, 1. My next point is 0, -1. Pi/2, 1. Sorry. Pi gives me 3. 3pi/2 gives me 1. And now I have one full cycle. Remember that sine ends on straight up and down. Do the best that you can to show that they're curved and not V's, and you have your graph. Our range is going to go from -1 to +3. If you need to, you can pause the video to catch up, but I'm going to go on to our next example. All right, example 6. We have 4 times the cosine of 2 times x minus pi/3. With this example, it's going to get a little tricky, but don't worry, I'm here to help. We can start off by identifying what are A, B, and now because we have a B value that isn't one, we need to factor this out. So what we're going to do is rewrite this parentheses, factor out 2. So now I have, I'm going to give myself a little more room, x minus, and then 2 times what gives me pi/3 would be pi/6. So my A value still is 4. That is my height of the curve. My frequency is 2. Remember that period is found as 2pi/b. So my period is actually pi. So one full cycle happens within pi, meaning 2 pi gives us 2 full cycles. Now my phase shift is going to be pi/6 to the right. And this is my starting value. I went to the right, so it's positive. I'll make this look neater. Okay. Now I need to figure out what I'm going to count by. So I take my period, which is pi, and I divide it by 4. So I have pi/4. So what you're going to do is add pi/4 to pi/6. Pi/4 plus pi/6. Get a common denominator. The easiest one I can think of is 12. By doing that, I'm going to end up with 5pi/12. And then you can just keep adding. Remember that pi/4, if you wanted to write it, is 3pi/12. So that's what you're just going to keep adding. So that will then give me 3pi/12 plus 5pi/12 gives me 8pi/12, which reduces to 4pi/6. 4pi/6, or again, you could think of it as 8pi/12, plus 3pi/12 is going to give us 11pi/12. Don't be a fascist. And 11pi/12 plus 3pi/12, again, we're using 3pi/12 as our pi/4. It gives us 7pi/6. And I always find it so satisfying to look at my starting value, which is pi/6, and my end value, 7pi/6, knowing that the distance is pi, which is one full period, which makes this all work out so beautifully. So you might be thinking to yourself, well, let me just label this. And notice that with our last graph, I didn't just, I went by pi/2 because that was easy, but I made sure that all of my values in the table were included. If we look here, if I go by pi/6, then when I have 5pi/12, I'm going to have to estimate that between 4pi/12 and 6 pi over 12, which makes it a little bit harder. So actually I'm going to count by pi over 12. So let's do that together. Pi over 12 plus another pi over 12 is going to be 2 pi over 12, which is pi over 6. 3 pi over 12, which is pi over 4. 4 pi over 12, which is pi over 3. 5 pi over 12, which is nice because that's a value we need, and that doesn't reduce. Then we have 6 pi over 12, which is pi over 2. So notice by counting by 12s, if you don't want to label each increment, but rather label the first and then some key ones, that's fine too, but I'm going to go ahead and keep going. So we had, 6 pi over 12. Now we'll have 7 pi over 12, 8 pi over 12, which can be reduced to 2 pi over 3, 9 pi over 12, which can be reduced to 3 pi over 4, 10 pi over 12, which reduces to 5 pi over 6. What did we leave off? Not the 9, 10, 11 pi over 12. Again, that's a value we need from our table. And then we would have 12 pi over 12, which is pi. Keep going. That would be 13 pi over 12. 14 pi over 12 reduces to 7 pi over 6. 15 pi over 12. Now, you could stop there knowing that that's where it ends. If you'd like to keep going, you can. I just left it at 5 pi over 4. You would have over here would be 3 pi over 2, and 2 pi would be all the way over here off the table. I also like to label just the negative side to show that that's what I am going by. Then on my y-axis, I'm going to go by 1s, which is cutting it close since my amplitude is 4. Thank goodness there's no phase shift. I'd have to go by 2s. And now we're ready to graph, except for now I didn't fill out my y value. So remembering that we're starting with cosine. Cosine originally starts up at the highest, the maximum point with 1. So it goes 1, 0, negative 1, 0, 1. Our amplitude is 4. And since there is no vertical shift, just by multiplying by our amplitude, we are done. You should be masters of transformation of functions by the end of this year. We've done so many. 0 and 4. All right, now we're ready to graph. So at pi over 6, instead of at the origin, we're shifting our graph pi over 6 units to the right. So we start off at pi over 6 and 4. Then our next value would be 5 pi over 12 and 0. Notice the midline is still at your x-axis. Then we have 4 pi over 6, which actually, sorry, that could have been reduced. No one stop me because this is a video and, you know, that's just how life is. It should be 2 pi over 3. Oh, now that looks like 21. Oops. All right, 2 pi over 3. 2 pi over 3 is going to give us negative 4. 11 pi over 12 is 0. And 7 pi over 6 is positive 4. I know it's very easy to try to make this a V, but remember that cosine is actually a curve, so we want to be very much aware of that. So when I draw this, I'm drawing it and show that it's not going on forever, just to show you don't do that. All right. We want curved ends to show where the maximums and minimums are. All right. Cosine has curved ends. Sine goes up towards its next value. So our domain is all real numbers. And our range goes from negative 4 to 4. Right. Next example. Here we have a negative 1/2 sine 4x plus pi, factoring out our frequency. So I would end up having 4 times x plus pi over 4, which means I have a phase shift of pi over 4 to the left. So my starting value, negative pi over 4. You haven't noticed already where your phase shift is your starting point. If you don't have a phase shift, then you're starting at 0. Kind of easy to remember that way. Our amplitude is positive 1/2, but remember we're going to have a reflection. Sorry, my handwriting's being sloppy writing on the computer. Our frequency is 4. Remember that our period is 2 pi over b. So we're going to have 2 pi over 4 or pi over 2 as our period. So if that's my starting value, I want to figure out what I'm going to count by. So our count by, we take our period pi over 2 divided by 4 or multiplied by 1/4, remembering that those are the same things. So I end up getting that pi over 8. So let's do that. Pi over 8 adding to negative pi over 4. Negative pi over 4, or you could write it as 2 pi over 8 plus pi over 8 is negative pi over 8. Adding pi over 8 would give us 0. Adding pi over 8 would give us pi over 8. And adding pi over 8 would give us pi over 4. This one was kind of easy to count by as you went through. Notice that the distance from negative pi over 4 to pi over 4 is 1/2, right? Negative pi over 4 to 0 is pi over 4. 0 to pi over 4 is pi over 4. And 2/4 is 1/2. All right, our sine function originally started at 0, but we're going to multiply by negative 1/2. So we'll still have 0, and we'll have negative 1/2, and we'll have 0, positive 1/2, and 0. As you go ahead and label, again, you don't have to label every increment. I am just to keep myself organized, making sure I don't skip something. 4 pi over 8. Wow, flip those around. See, it's so important to keep yourself organized. 8 and 4. If you wanted to, you could count by 8 and see where where 2 pi would be, but this is just fine. For myself, I'm going to go by increments of 1/2, just so it's a little bit easier to see an amplitude too. So at negative pi over 4, I have my value of 0. Negative pi over 8, I have negative 1/2. And then I have 0, 0. Pi over 8, positive 1/2. And 0. And because it's a sine function, I don't curve the ends, but rather show that it continues to go. If this were to continue to keep going, you could even sketch it out to see. But since we only want to graph one cycle, we don't need to do all that. So our domain is all real numbers, and our range goes from negative 1/2 to 1/2. Okay. And one last example, and then we're done. Hopefully it's getting a little bit easier. All right, here we can see that our amplitude is 1. That makes it nice and easy. Our frequency is pi over 3. And the reason I'm showing us this example is because notice that pi over 3 x minus 2 is not in parentheses. So actually this is going to be our vertical shift. Which will be down 2 units. My period, since my frequency is 1/3, remember, period is 2 pi over b. So my period is actually 6 pi. It takes a lot. So we only have 1/3 of cosine within 2 pi. So it's going to be a pretty wide function. We can start at 0 since there was no phase shift. What we're going to count by is going to be 6 pi divided by 4, which reduces to 3 pi over 2. So let's add 3 pi over 2. Add 3 pi over 2, you get 6 pi over 2, which gives us 3 pi, which makes sense. So it's halfway to 6 pi. Add 3 pi over 2, we get 9 pi over 2. Add 3 pi, and we'll get 12 pi over 2, which is 6 pi. Notice the distance from 0 to 6 pi is 6 pi. Cosine would start at 1, 0, negative 1, 0, 1. We don't have an amplitude, but we do have a vertical shift down, so everything is going to be subtracted by 2 to show that our midline is now y equals negative 2. So we have negative 1, negative 2, negative 3, negative 2, negative 1. My suggestion for counting by on your x-axis, I wouldn't go by pi over 3. You can. There's nothing wrong with that. I'm going to go by pi over 2's. You can count by whatever you would like when you're graphing, as long as it's the same increments. Like I can't write pi over 4 and then pi over 5 pi over 6 next to it. I have to go by set increments, just like you would on a regular coordinate plane. And I'm going to stop there. Negative 1, negative 2, negative 3, negative 4. Put a 1 here, here's 0. And we can go ahead and graph. So we have 0, negative 1. And then 3 pi over 2 is negative 2. Notice that that is now my midline, y equals negative 2. I have 3 pi is negative 3. 9 pi over 2 is negative 2. Again, that's my midline. And then 6 pi is negative 1. Cosine, we're going to show that it's curving. Down and back up and curve, showing arrows at the end. So notice a full cycle is within 6 pi. 2 pi is only a third of the graph. So that's really important to see. That's why our frequency is 1/3. Our domain is negative infinity to infinity. And our range goes from negative 3 to negative 1. I hope that you found these examples helpful, and there'll be more practice for you to do. Tuesday is our quiz, but Monday will be a live lesson for us to review together. I hope everyone stays safe and well. Have a good evening or day, depending on when you're watching this. Have a good one, guys.